Okay, so now this problem is again assessing application of Clausius Clapeyron equation. So this is problem number 6.4 in your book. So the question is pure ethanol boils at temperature of 63.5 degrees Celsius at a pressure of 400 torr. It also boils at 78.4 degrees Celsius and 760 torr. So basically now we got two temperatures and two pressures. Using only these data, estimate the saturation pressure for ethanol at 100 degrees Celsius, which is another temperature, the third temperature, and we need to calculate third saturation pressure, and heat of vaporization is not given. So that means in this case we need to apply Clausius-Clapeyron equation two times. First time when we will apply, we will calculate heat of vaporization, and when we will apply for the second one, we will use that calculated heat of vaporization, and then we will calculate P3 sat. Now as usual, first we will get the data. So the data is temperature T1, which is 63.5 degrees Celsius. That can be converted into Kelvin using 273, so which is 336.5 Kelvin. P1 sat is 400 torr. Then the second temperature T2 is 78.4 degrees Celsius. We can convert this into Kelvin using 273, and that becomes 351.4. So this is 351.4 Kelvin. And P2 sat is 760 torr. Now estimate saturation pressure for ethanol at 100 degrees Celsius, which is T3, which is 100 degrees Celsius. We can convert this into Kelvin by adding 273, which is 373 Kelvin. And P3 sat is unknown. We need to calculate this. Now we can apply Clausius-Clapeyron equation, which is using P1 and P2, mean first reading and second reading, minus heat of vaporization, which is unknown. We will calculate in this equation. R must be given. T2 minus 1 over T1, right? And R value is 8.314 joule over mole Kelvin. Now we will put all the values, which is ln P2 sat is 760 torr and P1 sat is 400 torr is equal to minus heat of vaporization divided by, we can put this in kilojoule, by 0.8314 kilojoule over mole Kelvin. So this is 0.8314 kilojoule over mole Kelvin. T2 is 351.4 Kelvin minus 1 over T1 is 336.5 Kelvin. So basically this is, we are applying the Clausius-Clapeyron equation first time, and we can get heat of vaporization by solving this equation, and that is approximately, you can use your calculator, 42.39 kilojoule over mole Kelvin. So basically this is heat of vaporization. So please use your calculator and try to solve this equation and check if you get the same answer. Now basically this is not because we were not interested in delta H of vaporization, and this was not the question, but we need to calculate this heat of vaporization for the next part, which is P3 sat, which is third saturation pressure. So now we will apply to get P3 sat, we need to apply Clausius-Clapeyron equation again. So now we will do second and third reading. Initially we applied for Clausius-Clapeyron equation for P1 and P2. Now we will do P2 and P3 because P3 is unknown. So now we can apply the same formula again in terms of P3 sat over P2 sat is equal to minus heat of vaporization divided by R. Now here we will use T3 minus 1 over T2, right? Now we will just put the values because we got all the information except P3 sat. So ln P3 sat over P2 sat is 760 torr, which is given. Delta heat of vaporization, which we have just calculated, this is 42.39 kilojoule over mole. I think this is kilojoule, not per Kelvin, divided by R, which is 0.8314 kilojoule over mole Kelvin. And here we got T3 is 100 degrees Celsius, which is 373 Kelvin, minus 1 over T2, which is 351.4 Kelvin. So basically this is what we got. Now we can just cancel few things. So Kelvin, Kelvin and Kelvin cancelled. Mole and mole cancelled. kilojoule cancelled. So here it will be tar, right? So basically, what we're gonna have, if you see, we have only one unknown, which is P3 sat, and we will use anti-log in this, mean exponent, and we will solve this equation using your calculator, and as a result you will get P3 sat is equal to approximately 1760 tar, and that is equivalent to 2.32 ATM. So basically this is your answer. So in terms of P3 sat. So summary is basically you applied in this case Clausius-Clapeyron equation 2 times. First time you use for P2 saturation and P1 saturation, and second time you do this for P3 saturation and P2 saturation. P3 saturation is unknown, so you calculated this, and you calculated delta heat of vaporization when you applied this Clausius-Clapeyron equation first time. So this is your answer in the end, and please practice this question and use your calculator to get the similar results, because this is tricky, because anti-log is involved or exponent is involved, and there are different numerators and denominators are involved. So please practice this question using your calculator. So I hope this question is clear to you guys.